Good evening. From the Gale Lumron Auditorium on the campus of Embry-Riddle, welcome to the Embry-Riddle Speaker Series. I'm Marc Bernier, the moderator for tonight's event. Over the last couple of years, we've veered off some of our political and public policy discussions to focus on the planets, the inspiration of Reverend David Keck. What if we did something with the words, music, and images of the planets? Following Jupiter and Mars, we are now heading in another direction, this time to Venus. We have three star-studded panelists with us tonight, and we're joined once again by the PEP Band, which is under the direction of Carter Reel. He is stepping in tonight. He is the president of the PEP Band. So I'm going to introduce our panelists and then bring Carter up to speak with us. It is Dr. Ashley Kehoe, assistant professor of astronomy. Is it Kehoe or Kehoe? Kehoe. New mommy, too. So it's the first night away from the baby. Ooh, should be a story later, huh? Also, Dr. Jason Aufdenberg and Reverend David Keck, university chaplain, with us as well. So I'm going to ask that Carter come up and speak to you about the music you're going to hear. The PEP Band will play, then we'll go into our discussion, then we'll take your questions from the audience. Carter?
Thank you.
What will we begin with first?
Our first piece is a medley of songs from a suite called The Planets, written in 1914 or 1916, with its debut in 1920 by the English composer Gustav Holst. In total, there are 7 pieces in the Holst suite for orchestra, one for each of the planets in our solar system, except for Earth and for Pluto, since the latter had not been discovered yet when the composition was scored. Listen for 3 of those 7 themes in our first piece, The Planets. Okay, there we go. Holst drew his inspiration for the planets from the astrological significance or action of each of the bodies. He said that if any guide to the music is required, the subtitle to each piece will be found sufficient. In the medley, you heard the first, Venus, the bringer of peace, with its slower tempo, muted dynamics, and melodies with small changes in pitch, each note followed by just 1 or 2 steps higher or lower than the previous. Followed this is Mars, the bringer of war, a bold piece with sharp attacks and powerful march in a 5/4 time. It feels very foreboding and intense. Finally, there were 2 themes from Jupiter, the bringer of jollity. Holst said of this planet, Jupiter brings jollity in the ordinary sense and also the more ceremonial type of rejoicing associated with religious or national festivities. In Modernity, this piece appears in multiple religious settings. Holst's planets gained notoriety from some elements that are unique for its time. In Neptune, the Mystic, a chorus of women were placed in an adjoining room to the auditorium, and the door slowly closed to create a fade-out at the end of the piece. The original composition of Jupiter is written for a full orchestra with a unique requirement of having no less than 6 timpani, sometimes 8, and 2 musicians to play them. The next song you're about to hear, Venus, is far less complex in terms of novelties, but is unique in that Holst does a lot with relatively few notes. Listen for thoughtful melodies that start with the bright major chords and end with pensive minor or tritone sustains, which add sort of a question mark to the end of the phrase. The theme is neither wholly pensive like Jupiter, nor intense like Mars. We hope you enjoy the colorful variety of Venus, arranged by Jay Bokuk.
Carter had to step in for Brian, who couldn't be here tonight. So we're going to ask them if they have a seat during our discussion that begins right now, and then the band will come back and sort of play us out, if you will. And remember, for those students who just joined us, we're going to go to Q&A questions from you, and please identify your name and your year of study. Okay, joining us for our panel discussion, Dr. Ashley Kehoe, of course, Assistant Professor of Astronomy, Dr. Jason Aufdenberg, Professor of Physics and Astronomy, Dr. David Keck, who is the University Chaplain. All 3 have been with us for all 3 of these years. We'll look at the planets. Let's begin with you, Jason. And there are many firsts in planetary exploration were made exploring Venus. It is a planet that we've also looked at as possibly for exploration, I don't know if living, but exploration. What were some of those first?
Well, it all sort of starts around in 1962 with Mariner 2 flying by Venus. That was the first planetary encounter, in fact, with a mission. And then it's sort of followed up by the first probes that actually entered by the Soviet Union entered the atmosphere. Many of them didn't make it all, well, they made it all the way to the ground, but not alive. So they would it got hotter and hotter and hotter. And then what they realized was that their parachutes were too big, and they were going too slow down through the atmosphere of Venus because it's such a thick atmosphere, and their batteries were running out. Essentially, they were running out of power. So they sent so many missions that gradually they made the parachute smaller, and they were able to reach deeper and deeper. So it was the first in situ measurement of a planetary body. So these were the first probes to go to another planet and be ensconced in its atmosphere and actually sample it. So that's an important first.
And I don't know how far you want to go into the weeds on this, but isn't the gravitational pull like several times what it is on Earth?
It's almost identical. So Venus is the evil twin. It has the same radius and mass, but quite different properties on the surface.
Talk about the surface at high pressure and temperature. It's a changing place. Because I know that a lot of Venus had volcanic rock.
It does. So it's like being under 3,000 feet of water. So 90 bar, or 90 atmospheres. So very, very crushing pressures and very warm, 500 Celsius, something like that. There is a bit of relief on the planet, so you can escape up to the highest peaks, 11 kilometers up, and it's only 40 atmospheres and 250 Celsius.
Let me leap over to Ashley. Talk about the phases of Venus's importance, to understanding the structure of the solar system.
Yeah, so back when Galileo was observing the phases of Venus, people still weren't sure if the Earth was at the center of the solar system, which we call a geocentric model, or the Sun was at the center of the solar system, which we call a heliocentric model. And it was his observations of the phases of Venus that really put the nail in the coffin of the geocentric model, because you can have phases of a planet, like the moon has phases and it orbits the Earth, but you couldn't have the phases of Venus when we saw them and have it be orbiting the Earth. So it could only work out if the Earth and Venus were orbiting the Sun and Venus's orbit was interior to the Earth. So those observations of the phases and when you saw a full and when you saw a crescent really put the nail in the coffin of, you can't have a geocentric situation and see what we observe.
What about the transits of Venus?
The transits have been a really important thing in determining not only the structure of the solar system, but the actual size of the solar system. So a transit is just when Venus goes in front of the sun. So it's sort of similar to an eclipse, except for in an eclipse, the moon actually went in front of the sun. It was big enough to block the whole sun in the total eclipse we had last year. But a transit, Venus is very small, so it just goes across. When it was first observed, they referred to it as a mole on the face of the sun. But they realized very quickly that if you observed it from different places on the Earth, it would look different. And you could actually use that to calculate how far away Venus is from the Earth and how far away the Earth is from the sun. If you hold up a finger in front of your nose and blink your eyes, you can see that the background changes. So your finger is Venus, and your eyes are telescopes on two different sides of the Earth. And the background changing, nobody's doing it, I thought everybody would do it. The background changing is the different positions of the transit of Venus across the sun. So you observe it over here, you observe it over here, you know how far apart your eyes are, how far apart those telescopes are. And with some pretty simple trigonometry, you can work out then how far away your finger is, how far away Venus is from the sun. And the reason why this was so important is because at the time we knew only the relative positions. So Kepler's third law tells us that there's a relationship between the period, how long the orbit takes to go around the sun, and the distance from the sun of each planet. And that's equal to a constant. So if you can solve it for one planet, you know it for the whole solar system. And we knew the periods of all the planets, but we didn't know the relative distances. So using the transits of Venus, they also used Mercury, but Venus was a better one. Using the transits of Venus, they were able to work out how far Earth is from the sun, how far Venus is from the sun, and just like that, we knew the size of the entire solar system.
What is exoplanet atmosphere, and how do transits relate to that?
So the first transit of Venus was recorded back in 1032, I think it was, quite a long time ago.
Who knew?
Well, it's funny because some of the, I guess David may talk to as well, some of the ancient cultures observed Venus quite heavily, but they hadn't yet been precise enough to see that Venus transits. So the first one that's recorded in history is about 1,000. And then Kepler predicted one, but he didn't know where on Earth you could observe it from. So just like with the solar eclipse, we couldn't see the full eclipse from Florida, so we knew when it was going to happen, but we had to know also where. You know, we had to drive up to Tennessee. So Kepler knew when it was going to happen, but he didn't know where on the Earth. So it was actually quite an interesting story. There was an astronomer in England who was only 22 years old when he died, and he was a self-taught mathematician, and he calculated and observed the first transit. And that was in, I believe, the mid-1600s. So he was the first one to, and the most exciting thing about this is he observed it from England and didn't get clouded out.
Yeah, this is a very important point I want to get our panel to talk about. The planet has been seen a couple of times during the bright of day. And did people freak out? Did they know what it was? Did they think the end of the world was coming?
It is the planet most often confused for a UFO.
Really?
It does have that distinction, yeah.
Okay. Before Frankie Avalon discovered it, Venus was always known to be the goddess of love. And from our cultural standpoint, David, how has Venus fit into our culture and to our history?
Yeah, as you can see from some of the slides we've been showing, you've got the images of the planet as well as images of the depiction of the goddess Venus, but there's also a Mesoamerican calendrical reckonings and understanding of connecting this heavenly body with a deity in many different cultures. So one of the things, reason why we started this series is to look both at the science as well as the culture, and I like to think of just the imagination. So if we start with sort of a raw experience of looking into the sky and seeing a really bright object that's not the sun and not the moon, and then you combine that with its curious pattern of when it appears, either in the morning, sometimes during the sunlight, and then in the evening, you've got something really bright and really sort of appearance at a certain time, disappearance to the naked eye, and then reappearance. And these, I'm thinking those are probably the two most, correct me if I'm wrong, but sort of the most powerful parts of the experience. And it's interesting to see how different cultures have combined those and given meaning of different kinds. So if you think about what something is really bright and a shining light in the darkness, not the moon, but again, so this image, this experience, what is that going to represent? It can represent a number of different things. And with the language of Venus, we tend to associate with, in Western culture, coming out of the Greco-Roman tradition, images of beauty, connections to Greco-Roman mythology, and then some of the paintings there, and since the picture of the Birth of Venus by Botticelli. But that image of brightness doesn't have to be just beauty. It doesn't have to be associated with the feminine. And so different cultures have had different interpretations. So if you want to keep going, or we want to...
Well, I want to ask Jason about the isopropes that have been used. And what did they find?
Well, many of the most important probes, so the Russians in the early Venera work were able to use radar to penetrate the clouds, and they did just the polar regions. And the first U.S. mission, Pioneer Venus, was the first ones to really map out pretty much the entire surface. So we knew where the continents were, where the lowlands, there are a few highlands we want to call continents, and then the lowlands. And then in the early 90s is when the first mission, and that was mapping things about at a resolution of a few kilometers. But then Magellan came along, and it had a lot of firsts there too. It was the first interplanetary mission to be launched from the space shuttle. It was the first to use aerobraking. So when Magellan got to Venus, it was in this highly elliptical orbit and actually dragged itself through Venus's atmosphere to circularize the orbit. And then when it got there, it started mapping. It would send a radar pulse down, it would bounce off Venus, and then it would move in its orbit and capture its pulse back. And the amount of intensity it got back depended on whether the surface was smooth or rough. So we sort of got a smooth, rough map of the whole down to about football field size resolution all over the surface. And one of the most important things we learned was that it doesn't have that many craters, and they're all uniformly distributed. They're randomly distributed all over the surface. They're not like on the moon, there's heavily cratered highlands and these big seas that don't have very many craters at all. Not like that on Venus. They're like uniform. And there's so few of them that indicates that the surface is only 800 million years old, which is pretty young considering the planet itself is 4.5 billion. And so something dramatic has happened to resurface the whole planet fairly recently.
I'm going to ask some basic fundamental questions too, because it's a mixed audience. Who discovered the planet?
Who discovered the planet? We
Do
do
they
not.
give credit to one particular scientist or person or nation that discovered it? Like we heard that as we gradually found the other planets in the solar system.
Well, it's the third brightest object in the entire sky after the sun and moon. So,
Let's start naming them. So they named this. this one.
so So it's no one discovered the brightest things in the sky, or they didn't. It was before written history. So
Yeah, a lot of cultures observed it, but they didn't know that when they see it in the morning and when they see it in the evening that it was the same object. They thought it was two different objects. So it was only when they started working out, Pythagoras started working out the orbits that they realized their evening star and their morning star were actually the same body.
Because of the resemblance to the Earth, does it have a north and south pole? Are there poles where the temperature is or the gas is of a specific density?
Well, it has poles in the sense that it rotates, but I don't think you get the temperature differences like we do on Earth because of the atmosphere being so heavy.
yeah, we're tilted over 23.5 degrees, but Venus is tilted over 278 degrees. So it's just two degrees off from straight up. So it has no seasons. And it's pretty uniformly, the main temperature variation is in height, but not in latitude.
Yeah, I think it wouldn't have seasons anyways because the surface temperature gets regulated more by the
Yeah, by the
atmospheric
big
clouds
greenhouse
than
gas, right.
So you can cross this off for interplanetary vacation travel. All right, what about, they used radar to probe through the gas at one point? How
Yeah,
did that work out?
several times, right, with Pioneer Venus and then with Magellan. So not only they found the lack of craters, but also most of the surface is in kind of this smooth lowlands. And if you look at the Earth, we have continents and seafloors and trenches. So we have like this dichotomy between the high stuff and the low stuff. And in Venus, it's all just this continuum of up and down. It's like the distribution of heights is pretty different on Venus. So it's something about its geologic history is different on Venus.
For both of you, there were some woes in the early history of the discovery of Venus. All three can jump in on this. What were those woes? What were they thinking?
Well, it wasn't in the discovery of Venus. It was in trying to observe these Venus transits. So I said the guy first observed it. Jeremiah Horrocks was his name, just since he died so young. Say his name right there. So he was the first one to observe it and predict it. And then they knew they would happen again every century or so. So they knew there would be some more in the mid-1700s. And this was actually the first time that people really sort of went on scientific expeditions. And so they took their telescope and they went in the boat and they said, we can only observe the transit from here and here, so let's go there. And so there was a poor French astronomer named Le Gentil. If there are French people that want to correct me on that, I'll be happy to take a correction. But so he was going to go to Pondicherry, India, because that was going to be one of the spots you could observe this mid-1700s Venus transit. And you always get two transits 8 years apart, just because you only observe the transits at the nodes, but the sun is basically big enough you get coming back to the node twice. So he went there for the first one, I think it was 1761. But when he got there, he thought Pondicherry was a French colony, but the British had taken it over, so he couldn't actually dock and come on shore to make his observations. So he was still at sea. But then he said, what, I've come all this way. There's going to be another one in 8 years. I'll just hang around and observe it then. So by then, Pondicherry was back taken over by the French, so he could come on shore. So he built himself an observatory just for this transit, and he got clouded out. So way worse than we have today. But then the worst bit was, so then he sailed home in defeat. But it took him so long to get home because, back then, people were getting scurvy and whatever diseases they got. And by the time he got home, he'd been gone for 11 years. So they declared him dead. So his wife had remarried. They'd sold all of his belongings. His property had been taken over by his heirs. But despite his hardships, this mid-1700s transit of Venus, they were able to calculate the distance between the Earth and the Sun to within 2%. So it was worth it. Maybe.
It's amazing. Are there any kind of moons or substances that circle the planet of Venus?
No moons.
It's
No
one of the
moons.
few
So not
planets
like
without
Mars
moons.
where we have, Phobos and...
Deimos.
Deimos, right? Yep, no moons. And so its mass wasn't very well known until the probes were flying around it, because you need to have something going around something else to weigh it. And so the full understanding of how twinish it was, that it had this similar mass to the Earth, had to await spacecraft and its perturbations on that. One of the wows of the landers, so they went through the atmosphere, they measured it was mostly carbon dioxide, we're mostly nitrogen, oxygen, and the third trace constituent of the Earth's atmosphere is argon, so they're expecting to find argon.
Well, I'm sorry, what is argon?
Argon is one of the elements of the periodic table. It's a noble gas. It's kind of like a heavy helium. It's got 10 protons, 10 electrons, and it's a very stable noble gas. Doesn't really react with anything. And so it's easy to sniff out, I suppose, one of the easier things. It doesn't create molecules that you have to break apart. It just stands alone. And so it's one of the things you like to sniff out if you land on a planet. And they found that, the distribution of different argon, so atoms come in isotopes. You can have all the argons in the world in the universe have 10 protons, but they have different number of neutrons. And so some of them are argon-36, and some of them are argon-40. Oh, I said 10. I meant 10 for neon, but anyway. Anyway, they're isotopes for argon, and they found much less argon-40 than they expected. And where does the argon-40 comes in? It comes from the same place that your bananas. Bananas have lots of potassium in them, and whether you knew it or not, the potassium in your bananas is decaying into argon. And so most of the argon that we expected to see on Venus was from the decay of potassium, the radioactive decay of potassium. And they didn't find nearly as much argon as they expected, like a lot less, 10 times less or something. And so that meant that this potassium rock was not coming out of the volcanoes to make the argon. And so it's like, yet another thing we don't understand about Venus was why there appear to be lots of volcanism everywhere, but it's not spewing the kind of rock out of the volcanoes we expect. So there's something about the chemical history that's not releasing argon, the right kind of argon, into the atmosphere. And so that's another sort of chemistry puzzle of the whole, how the air and the land interact over time and distribute the chemicals around Venus is something we still don't understand.
Is there water or ice of any kind in any rock to our knowledge?
No, we think that it basically baked out all the water, if there was any, and was so hot it broke the water into hydrogen and oxygen, and then the hydrogen left. And all the oxygen got bounded to carbon and made 98% carbon dioxide. So you couldn't even make water. You'd have to bring a whole bunch of hydrogen to the planet, tear the carbon off the oxygen, and then make a whole bunch of water. But so you can't go back. No more water.
So knowing all this, and there'll be a test at the end of this evening, why would there be talk about going to Venus then? What does Venus have that we would want? Or is it just, it's there, so let's go there and take a look?
Well, you start out with two planets. They're the same mass, they're the same radius. They're not too different in distance from the sun. Why are these completely different trajectories in their history? That's very interesting. We like to understand that.
What did Venus do wrong?
Yeah, did it?
Well, doesn't it take 243 days, didn't I read that, to go around? Is that correct?
Just to turn, yeah. So if you could see the stars through Venus, if the star is above your head, it would take over 200 days for that star to be above your head again.
And is it going around the sun?
It's a very long day.
It's going around the sun even longer to go around, shorter. I guess the day's longer than the year, right?
Yeah.
Or the sidereal day is longer than the year.
So is there a time in which it's closest to Earth?
Yes, yeah. So it laps us because it's going around more often. And so it laps us, and we see the same phases over a 584-day period. So we get Venus returns to the same phase that we would see. And there's a big connection with that because it turns out, and maybe David can expand on this for the Maya, but 5 of these phase cycles is almost exactly within a few days, 8 years. So this seemed very significant. So after 5 of these phase cycles, it returns to almost the same part of the sky, same time of year. And so the astrologists go nuts because it makes a pentagram.
Wow. You want to pick that up, David, or you want to talk about the cultural?
As a chaplain, I try not to pick up pentagrams, but nevertheless, Yeah, I think that with the Mayans, a great example. You've got this mathematical reckoning, very careful reckoning, which they build into their construction of buildings, patterns of not just of particular buildings, but also entire communities. And so as they observe these phenomena and to do these reckonings, there's got to be something to it. Right? I think there's just, again, that imaginative piece, that why is it that you have these patterns that recur? It must mean some form of symbol. Again, it's this bright image in the sky that has this pattern, this degree of predictability. Again, it's visible, not visible, visible. All of these suggest something is extremely important happening. Pay attention, human beings here on Earth. And so part of it, this bright object in the sky is associated with the deity. There's one of the slides here that has one of the formulations in this long Mesoamerican names that I can't pronounce. But it's a deity, it's a war deity in the morning, and this image of this bright object that has this pattern, this regular recurring cycles, is interpreted in male form, not the female form we have with Venus, and this image of bright light coming, and the rays of this light, to use that language, are imagined in terms of spears and arrows, and as threats and in danger and signifying war. So understanding when this war god is appearing in the heavens becomes really important for when you're going to go out to war,
yeah.
when you need to protect yourself. Yeah. And even on a daily basis or regular basis, you'd have sort of communities sort of concerned that the god in the sky just coming in is going to be sending these rays of death and disease, so cover your windows and make some offerings. So something big is happening, again, sort of bright thing, interesting patterns, there, not there, there, on the cycles of years, and pay attention. And so that's one of the things I find fascinating for the Mesoamerican cultures. It takes on this masculine form, this bright sort of association with war, but then also the whole language of death and offering and sacrifice. If you think about sort of their disappearing back, right? Sort of many mythologies interpret that in terms of a descent into the underworld. And so it's images of life and death, or if a descent into the earth. Descent into the earth can also be a descent of fertility, so associations with the fertility. So you've got war, death, fertility, sexuality, all of these images coming together. And again, go back to that primary experience, really bright thing, does something really curious in the heavens. What do we make of it? And this is before the discovery of argon 45(9.6, so, you know.
Yeah.
I'm curious if the Greeks or the Romans or Native American Indians ever revered Venus for any reason. If it was part of their culture, if it was part of their god system that they prayed to. Do we have any knowledge that other cultures have held Venus in high esteem?
Well, a lot of them did. I mean, they all thought it was a star, of course, because it's so bright. Venus is bright enough to cast a shadow even, and it was much brighter back then when they didn't have all the light pollution. But a lot of them didn't know that it was the same star they saw in the morning and evening. And then the ones that did work that out, I think this whole sort of like war thing was, you always see Venus near the sun because it's interior to the Earth's orbit, so you saw it at dawn or at dusk. And so sometimes you see it sort of going into the sun, so they thought of it as getting like gobbled up by the sun. And then sometimes you see it moving away from the sun, so they thought of it as winning and escaping from this monster that was the sun. And I think that goes back to the whole war.
You know, I keep wondering why.
And death and rebirth,
Yeah.
too, like it dies and comes back.
You're the scientist, so forgive me for my Cracker Barrel question here. I often wonder why the sun doesn't just pull it in or has some reaction. Do pieces of Venus ever break off and fall to the Earth?
Well, it's
Any knowledge
interesting.
of
There are
that?
definitely pieces of Mars that have certainly
Yeah.
broken off and hit the Earth. I think that the challenge is the higher gravity on Venus, so it's harder to, you need a lot more energy to, so you imagine a really big comet or asteroid hitting Venus. It's got to get through the atmosphere. It's got to knock a chunk off. That chunk has to get out of the atmosphere without burning up.
Yeah.
And then get back to Earth. So I think the challenges of Venus with its thick atmosphere are, and that's what you see on one of these impact craters. On the moon, the ejecta from the craters is really uniform and symmetric pretty much. But imagine your asteroid coming in, hitting the surface of Venus, and then being thrown up into this gas that's at a pressure of 100 atmospheres. It gets entrained in that gas and falls back in the kind of, very artistic, asymmetric ways.
Venus is too far a way to be viewed as something in an eclipse? Is that correct?
Well,
Or do you ever see
it's a
anything?
transit, right? So they viewed, like if Venus were big enough to block the whole sun, then it would be an eclipse, but it's basically the same thing. It's going across the path, so it's all lining up, Earth, Venus, and sun, but it's just so small. You see it as, they called it a mole on the face of the sun.
Go ahead,
One of the slides had a picture of someone looking at a projection through a tube or a telescope. I'm not sure what the device would have been, because you can't, just like I'm trying to look at the sun there, that bright light up there, I'm just going to, and so I think it took a while for them to figure out how to be able to do that observation.
I think historically sandstorms and other kind of unique events would make the sun visible. I know sunspots and other things were viewed historically, and under the right conditions you could change the contrast and see spots on the sun, but you need the right conditions or you go blind like Galileo.
So if we've had devices on the planet, are there materials, minerals, or substances that might be of value to Earth on Venus?
It's made of the same stuff. We got lots of basalt here, so you wouldn't want to really set up a basalt mine. Just because of the extreme environment, wouldn't really be worth it. But then again, we really haven't, all the probes have pretty much landed in the lowlands. There's only one that even was kind of up in the slopes. And so we're kind of ignorant of direct samples of the higher continent. So on that map up there of blues and greens and reds, the reds are the highest parts, and the white's even higher. And so we really haven't, directly probed those materials, but we think it's mostly, it's all volcanic in origin. So we don't expect anything special, but we haven't really mapped it out.
But it sounds like that if we ever did go there, for any reason, we might have a lot of trouble getting off the planet, right? Because of the pull?
I don't think you come back.
Oh, it's not a sample return.
Sample
No,
return,
no.
right? That'd be the ultimate. That's really great. So all the probes, even the landers, the maximum time, lead melts in the surface of Venus. So the maximum time of these landers is about 2 hours before they stop transmitting. Things melt. In the Soviet systems, in the Soviet missions, they refrigerated the thing on the way down to make it last even that long. So what they're working on at NASA Glenn now is very exciting. They're working on computer chips that are made of silicon carbide, not silicon oxide. And these sensors work in jet engines. They're used to measure what's going on in a jet engine. So, hey, that's kind of similar to Venus in a way. And so at NASA Glenn, they actually have a vessel where they can bring the pressure up to 100 atmospheres. They can bring the temperature. They can even put it 98% carbon dioxide, and these things will last for weeks in there. It's got the computer power of the Apollo program. They have 1970s speeds, but the next landers could maybe last a month. So you can actually have a rover concept. The landers just landed. These things could be on the move, maybe explore their local environment a little more.
The theme is don't give up, though, because the Soviet missions, which they called Vernier, which is just the Soviet word for, the Russian word for Venus, it took them till 9, I think, to actually send back a picture of the surface. And then they went on through 15, 16, because each one would just get it like sort of a little bit farther in before it failed. You just get better and better.
Yeah, that was great. They had a couple missions where the lens cap never popped off. They had one where the lens cap popped off right under their soil probe. So they went to probe the soil and hit their lens cap. So the point is they sent so many that they eventually, try and try again.
Is it just us and the Russians that are interested in Venus, or the Chinese, are they into it?
The Japanese have the latest satellite. The latest orbiter is actually a Japanese orbiter, and they're finding very interesting atmospheric features. So they're not really probing the surface, but they're looking at the dynamics of the atmosphere. So that was launched in 2010, I believe. So the last probe, the orbiter. But probes, the next generation of probes is yet to be really funded through completion. So I think every year the Venus scientists are proposing missions, and they're just not as exciting as digging through the ice in Europa at Jupiter, or going to Saturn, boating through Titan's methane oceans. I mean, these things are hard to compete against. So.
As the Earth is to Venus, what is Venus closest to other than Earth?
Oh my
Mars?
goodness. Yeah, of the
Has an
terrestrial
atmosphere.
planets, I guess. It's What is it close to?
Nothing.
Not close to
Nothing.
Mercury.
Its thick atmosphere is definitely unique in that sense.
So we're better off trying to get something out of Venus, or looking the other way and going to Mars, or maybe, we've done Jupiter in this program. That's like a whole week. Saturn.
Well, they actually did, just at a conference recently, they did a discussion on, they had like geologists and climatologists and lots of different people, and it's like if you were to swap, so like Venus is too hot, Mars is too cold. If we were to swap the orbits, would we have gotten a better habitable planet forming in the solar system, and would we not be then the only habitable planet? But, of all the discussions that came out of that, the answer was like no, basically. So.
I'm thinking about from a cultural standpoint, some of the early movies that came out about outer space, and it seemed that there was either they came from Mars or they came from Venus. The fake aliens in the movies. And I'm, after hearing you all speak, I'm not even sure how anything from Venus would ever get here.
Well, there is a classic film which I've not seen, and given the nature of the slides, it's a little more racy. But I think it was called Vampire Vixens from Venus. But then again, that sort of sense of how that imagination works. In Western culture, we tend to associate Venus with romance, love, sexuality, passion. And so, yeah, sort of that image of the Martian, which we tend to think of as a warrior type. And then in that particular rendition was the sexuality, the passion, the romance, drawing off of that. And so some of the images there talk about or present the image of Venus as a goddess of love. You'd asked about sort of the veneration of the planet or the goddess. Romans in particular were dedicated to Venus in part because of their mythology about the origins of Rome. Venus was the mother of Aeneas, who was the founder of Rome. And so within Roman culture, as opposed to Greek culture, there was even greater role for Venus and greater respect. Dating back through sort of Middle Eastern images of Ishtar and other ways of understanding the significance of this being, Venus in Roman mythology tended to have a little bit more of the warrior aspect than we would have seen in the Greek mythology, more Aphrodite, and use the Greek term. Who would have been more associated with the romance and the passion and the sexuality. So different ways of, again, it's fascinating to see the ways which different cultures construct and imagine. So as we think about our science fiction, we very much come out of the Greco-Roman, and I think it's always an interesting leap to see people start referring to the Venus or the planet associated with the deity in a different culture using the masculine pronoun. So in Hinduism, for example, it's a masculine deity that's associated with that. And again, it's this odd sort of phenomenon. We get that. In Hinduism, you have, I think the name is Shukra, which literally means semen. And so this deity is, it draws regeneration and healing. Particularly was dedicated to the teaching of sort of righting the ways of demons within Hindu mythology. And again, that sense of image of motion, you're talking about those peculiar ways of relating to the sun, the sort of the motions and brightness, and this image of refinement comes out. And so this bright object is associated with harmony, with right order in a way that is distinctive in that imagination, so that the image of sort of passion and sexuality is bridled by, trained by, refined or purified by this understanding of the deity, who then moves from sort of base passion, material desires to sense of harmony, peace, beauty, order. And so that's within that mythology, you have this sort of a respect for the deity. And so how that can be possible or part of a person's life. Particularly in Hinduism, you also have astrology, which is still a very important part of Hindu culture. And so that aspect of understanding how you as a person and your birth date and your time relate to Venus is still very important for many people in Hinduism.
This may be a stretch, but just asking, is there anywhere either in the Bible, Old Testament, or in the Torah that makes any reference to anything that may even sound like Venus or one of the planets? Do they make any reference, or they absolutely don't? I've not seen anything, but you being my theologian here, I thought I'd ask.
It would be, I think, to a particular planetary body, not really. The ancient Israel is not particularly interested in astronomy, right? It's in a relative.
Yeah.
You know.
I think there was some pseudoscientist that tried to say something about Venus was the cause of the parting of the Red Sea, but I don't think he quoted to a specific Bible verse.
Yeah. And I think that the base, it's kind of interesting, I think, in whether it's in reaction to other ancient Near Eastern cultures, just just emphasis on monotheism and a rejection of, it's a curious, I would say relatively curious absence. There are other Near Eastern deities present in Scripture, but not in the same kind of way in terms of an association with a planet.
I mean, the Christmas star could have been Venus, for example.
Okay.
Guiding the wise men.
Okay.
Or it was UFO, or...
All right, now we're going to take your questions. We have 2 microphones set up. Let's have students or the general public. Please come down, ask your questions, get you on record in the program, your first name and your question tonight. You can address it to a specific panelist or in general. Good evening, and thank you for being with us. We have a microphone over here for students as well. Go ahead, sir.
Good evening. My name is Brad Canning. I'm a junior here at Embry-Riddle, and my question is actually for both Dr. Aufdenberg and Dr. Kehoe. Dr. Aufdenberg, if you could talk about the potential viability of a mission to Venus, which anyone in the astronomy club here at Riddle has seen the presentation, and then maybe if Dr. Kehoe could talk about why it might be more beneficial to go to Venus instead of Mars, and from the perspective of how long our astronauts are going to be out in space. Thank you.
So are we going? And why Venus instead of Mars?
Are we just going to orbit and not try to land?
In the cloud, it's like a 40-kilometer distance.
I didn't see that.
So that they can hear us on radio. You're talking about a potential breathable atmosphere. Would we be able to go to Venus?
Well, certainly, there have been, in the 80s, balloons were launched into the middle atmosphere. So one can imagine an intermediate approach where we launch more balloons and directly sample the atmosphere. As I mentioned, NASA Glenn is working on the technology, and there's several different, in that magazine piece, Tougher Than Hell, they discuss three different landing concepts with this new silicon carbide electronics. So I think that's going to push the duration. So I think people want to go back. They just want to, not human, but robots should go back, should go to the surface, but they should last at least 10 times longer, or maybe weeks or months to make it worth it, right? We want to stay longer on the surface. So I think there are opportunities for in situ balloons and for the surface.
Maybe it's more interesting because, well, we know a lot about Mars. For one thing, we've had a lot of missions to Mars, but Venus is more geologically active and it's more similar to the Earth. So maybe it's more interesting in that respect, in terms of like learning about our own planet.
Yeah, Mars is pretty dead. So it's half the size, which is 2 times 2. It's like half the size, right? So it's got 8 times less volume. So just less radioactive elements inside Mars. It's pretty much dead. Venus is the same size. So it's like a pressure cooker. It's got this big plate on top of it that's only 800 million years old, and something's going to happen. Basically, it's got the pot's lid is on the pot, and what's going to happen? So that'd be exciting. We get there, and then the the volcanoes really happen. So what they're interested in, some of the probes, right? We'd like to pierce through the clouds, see active volcanism. It should still be warm, so there should be active volcanism, and that we just don't have enough sensors really to see, is there active volcanism, is there active lava flows? We expect these things because it should be as warm as the Earth. It should have the capacity to generate volcanism, active volcanism. And if it isn't, we'd like to know why, and really, that's very interesting to me.
So am I hearing this correctly? We have active volcanism on the planet? Or
I think
we're
there's
not
been
sure?
some hot spots seen by this mission Venus Express, but it hasn't really been followed up, so it's tentative, I would say.
Yeah.
What do you think?
Well, I lost my train of thought.
Well,
Well,
one
there's
thing
active
that makes
volcanism.
Mars so interesting is back in the 17th century, you could see, through telescopes, you could see surface features. You could measure its rotation. Venus is completely boring at optical wavelengths. It's just this white thing, right? And so it's really been in the modern spacecraft era, where we really unlocked its secrets.
Yeah, and I guess, you were saying, people were asking the question that, if Venus is the Earth's twin and it's got this runaway greenhouse effect and we've got all this talk now about the Earth having the greenhouse effect. Will we end up like Venus? But I think you were saying no, because the sun would have to be 10% more massive to actually get us to that level of extreme.
Yeah, to get so extreme, you'd have to burn every fossil fuel and then some. So, but it's getting to 400 Celsius. Yeah.
I'm looking for others to come down and ask your questions. Come right down, please, from wherever you are in the audience. While we wait for a person to come, did I hear that because if we had all these fossil fuels going at once from every country, would we end up recreating the atmosphere that Venus has?
Well, we would certainly produce more of the greenhouse effect, which would raise our temperature, but we'd have to get more carbon. We'd have to really bake out the carbon more than just all the fossil fuels.
Gotcha.
I think it wasn't possible for the Earth to end up as extreme as Venus, given that it's slightly farther
Yeah,
away.
it helps to be a little closer to the sun, too.
But it's not to say we're not all still going to die. It's just not going to be that bad.
Cheer up. Over here, your question now. Good evening.
Hi, I'm Casey, and my question is, why does Venus rotate in the opposite direction as the Earth?
Good question. Why does it revolve opposite to what the Earth does?
I don't know if we know for sure what the answer. We expect everything to rotate and orbit in the same direction, because when planets are forming, you have this big disk of gas that's sort of all spinning in one direction, and it starts to collapse down, and everything's spinning together. So we expect planets to orbit in the same direction and to rotate in the same direction that they're orbiting. So the fact that Venus rotates in the opposite direction, it could be that it got impacted by something, so it just flipped it over. But you would usually get more effects from that. Like the Earth had a big impact, we got a moon out of it. So, why doesn't it have a moon or some evidence of a huge crater on the surface? It could also be, it seems, some sort of trade-off between, you got all these tidal effects from the sun. The sun pulling on the Earth causes the ocean tides that we see here, but it pulls on all the planets. So it pulls on Venus, you get tidal effects there. But then you're also getting some sort of weird tidal damping from the atmosphere, which is rotating at a very different rate from the planet itself. So maybe all of these things working together could have caused it, but I don't think I don't know for sure.
Yeah, just so that I don't get confused, are we counterclockwise or clockwise on this planet?
We're counterclockwise.
Down.
Counterclockwise.
Like a proper planet.
So it means but Venus is going the other way. Right over here, your question. Good evening.
Hi, I'm Steven. I'm a fourth-year aerospace engineering student, and as a sci-fi nerd, one of my favorite settings is the Cloud City in Bespin from Star Wars. So I was wondering, do you guys think that aerostat colonies on Venus would be a good idea? Like, is the atmosphere thick enough for that, or would that be better than a glass dome on Mars?
I haven't seen Star Wars.
Well, certainly it's almost easier in Venus. You have a lot of atmosphere to work with. And so certainly the balloons that were sent by the Vega missions, they were able to maintain a constant altitude and latitude and just moved in longitude around the planet until they lost signal. It went around to the far side. And so that has been done. As far as, you'd really want, we'd have to look at the temperatures. One thing that kind of came up was how fast the atmosphere was rotating. So if you're up in the upper cloud deck, you're pushed by the background winds, you're going to go around in 4 days, whereas the surface takes over 200 days to go around. So there's this incredible velocity gradient or change from the outside all the way to the inside, because it goes from hundreds of meters per second down to 1 meter per second at the surface. So one of the things that the Venera spacecraft saw when they got to the bottom of the cloud deck, it basically opened up. If you look at those pictures from the surface, you notice there isn't a really low ceiling. It seems way high, so the clouds are pretty darn high up there. So it'd be interesting to make something that could maybe survive at the base of the clouds, right, and kind of float around there. And it's still pretty warm up there. I'd have to look at the pressure-temperature profile, but as a scientist, I would want something to float just at the bottom of the cloud deck so it could just see down and look at everything. That'd be pretty cool.
Are you looking for a senior project? Is that what you're kind of,
Before we take this question, there was an image that was there. It was a gentleman who looked like a pilgrim. He said how he viewed the planet, and there was long light. Is that like a telescope? What is that?
It's using a telescope to project an image as opposed to projecting it into your eye. You project it. If you take the eyepiece out, you can just use, or you can use the eyepiece to project, You can do that. Often we do that at the observatory sometimes to look at the moon, because the moon's awful bright. And sometimes it's nicer to project the moon onto a piece of paper and just look at it. So with the sun, you can do a projection.
People
like
may have
that.
done simple versions of that for the eclipse last year as well.
Yeah, that was it's a safe way to look at an eclipse. It's a safe way to look at the transit. Yeah.
I love the images you brought, by the way, tonight. We have opportunities over here. If you want to come down and be in position to ask your question, let's go back over here. Your question for our panel.
I'm Jason. I'm a first-year aeronautical student, and you said that Venus was turned over like 270 degrees. Does that mean that the pole is pointed at the sun?
It's pointed sort of down at the south ecliptic pole, we would say. So instead of being pointed, so its pole is perpendicular to its orbit. So its axis of rotation and its motion are at right angles, except it's going this way and the Earth's going that way. 178.
Oh,
so
I thought
nearly
you said 278.
Yeah, 178. So that's within 2 degrees of 180. So we're rounding up a little bit.
All right. Yeah. Thank you.
Yep.
Got it? Okay. Hi, Alex. Go ahead.
Okay.
Hold on, Alex. We'll come back.
Cool.
You're all
Alex,
right.
I'm a second year, so I'm just wondering if we try to colonize Venus, how would being closer to the sun affect that mission?
Well, it's one of the interesting things that came out of the sort of thought experience about, if you put Venus at Mars's orbit, would it be cooler? And the answer was really no, it wouldn't be that cooler, because Venus being so hot is not really because of its location in its orbit. I mean, it's actually hotter than Mercury, and Mercury is closer to the sun, but it's hotter because it's got this runaway greenhouse effect. So I think, it would just, even if you were farther out or whatever, the heat there is just, is it 9?
So if there was a terraforming effect, let's say that greenhouse effect isn't there, would the sun then affect the colonization
is
mission?
Venus in the habitable zone?
No, I think it is not. It's a little bit too close.
The habitable zone is something that is an idea that came up when we started observing extrasolar planets, and it sort of says how far from each star could we have a planet that could develop potentially life similar to what we see on Earth, but it doesn't consider things like, do you have an atmosphere or not? So Mars is in the habitable zone, but I think you're right, I think Venus kind of isn't.
It's the Goldilocks thing, a little
Too hot,
too
too
cold, just
yeah.
right. It's just inside the just right.
Thank you.
Thank you. Back over here, your second part.
Yeah. You said that the winds aloft are really high, but the winds over the surface aren't that bad. Is that just because surface friction, or is there something else?
What explains the velocity gradient? Do we understand the extreme? I don't understand exactly. I know that's what's measured, but what it affects geologically is the wind is very thick but not moving very fast. So they didn't, when you look at all the radar images, you don't see extreme effects of erosion. Whereas on Mars has a thinner atmosphere than the Earth, but it has sandstorms, it picks up sand, and over time that sand dramatically affects the landscape. But when you look at the geological features on on Venus, you don't see evidence for erosion. You see a few wind streaks, you see the effects of the crater ejecta being flung around, but you really don't see a lot of erosion. So the idea of capturing wind energy in these next series of missions is interesting. It's not moving very fast, but there's a lot of it. So it can push on your little turbine and give you some energy. But the effect of the geologic effect of the wind seems to be kind of minimal, which is kind of interesting.
I think there's a lot of complicated turbulence and things, and that's one of the Japanese Akatsuki missions is looking at, trying to understand the structure of that.
Yeah, indeed. One of the things they just found was this 10,000 kilometer long feature in the atmosphere that went from the northern hemisphere all the way to the southern hemisphere. And it is not moving at this rapid 4-day rate. It seems to be fixated over a mountain range on Venus. And what they think it's related to the same kind of wave phenomena we see on the Earth, which are called gravity waves. So there's something about the atmosphere moving over this mountain on Venus, this big continent on Venus, that has created this feature. So there's still a lot we don't understand about features in the atmosphere, but that's why the Japanese mission is there, to help us understand that better.
We can take a few more questions before we ask the pep band to come back. Come right down, ask your question. Thanks for being with us.
Hi, I'm Drew Luneski. I'm a third-year student here at Embry-Riddle. So my question goes back more towards the terraforming. We obviously understand the genetic makeup of organisms that we have here on Earth, and we're starting to modify it, the genetic makeup of these organisms. Would it be possible to create or modify an organism that we have to begin to incubate on these planets, to begin to create a habitable atmosphere?
I think that was the plot line from Vampire Vixens from Venus. just you know.
Well,
They're going to breathe the CO2 and turn it into oxygen. Is that your idea?
A potential
they need
to do something
a
of those
CO2
sorts.
eater.
Yeah.
A scrubbing organism, if you will.
Yes, yes.
Well, a
Well,
lot of trees.
yeah, what I think about on the Earth are extremophiles. So we found organisms on the Earth that can live in boiling water in these hot smokers at the bottom of the ocean. And that would be the thing, right? How much more extreme can you get? You'd have to be a lot more extreme. So I don't know if any mad scientists are thinking along those lines, actually.
I mean, mad biologists.
Mad biologists, yes.
Are you looking for a senior project too? I mean,
We have a new aerospace physiology degree. Maybe they should be working on that. Yeah.
Got time for 2 more questions. If anybody wants to come down here and ask a question, come right down and join us. Thank you for being here tonight.
Hi, I'm Sean Reed. I am a second-year AE student here. I had a main question mainly about colonization of Venus. Mainly specifically, we always hear about occupy Mars and all that, but if you're given a choice between Mars or Venus and you're told you either colonize this planet or this planet, which planet would you go to and why?
Well, I don't know if we're, you're talking about being more advanced in these electronics that could survive on the surface, but I don't know if we have much technology in the way of helping humans survive on the surface. But we also don't have much technology in the way of helping humans survive on the surface of Mars still, because the radiation effects, because of Mars' lack of atmosphere, is just pretty insurmountable. And the most recent thing I've heard about is trying to sort of find these caves on Mars that we could live in, because the suits just aren't going to get it.
You need shielding from cosmic rays, basically. Yeah. So you go to Mars, you pop up, enjoy it, and then go into your underground cavern, which is better than getting crushed, burned, and then rained on by sulfuric acid. So,
too little atmosphere, too much atmosphere.
Mars all the way for colonization. I mean, Venus is tough.
Especially with Venus, there's, as Stephen had alluded to earlier, they say there's a habitable zone in the upper atmosphere, about 5,000 kilometers, they say, which is roughly close to there. That's why I was asking, do you think we could, in theory, have a human presence in that little zone in an airship or something like that? Or would Mars be a more suitable thing to go after?
I mean, it's interesting to think about, a blimp, a manned, humaned blimp.
No, I'll tell you what you want to colonize. It's not Mars or Venus, it's asteroids.
But you're biased.
Can we do an asteroid series?
Hey, I'm going to ask the PEP band, I'm going to take your question, ask the PEP band to assemble while they're getting them seated. We're going to take this last question, but a basic question. Did Venus have life at one point and then it just went away because of the atmosphere? Do scientists believe there was life on Venus?
Any evidence has been erased.
The hard part is the erasure, because the whole surface appears to be only 800 million years. We know some form of life was around on Earth way before then. So if the same thing happened on Venus,
could happen sooner even.
It could have happened even sooner. So in the early days, the sun was only 70% of its current luminosity. So Venus could have been in the habitable zone earlier, actually. It may have been.
And the carbon dioxide, the atmosphere, all that wasn't
would have been less. Yeah. So there could have been a period. The problem is that it resurfaced itself, and with it, all the fossils and the radio telescopes, anything else that was made during that time got covered over.
So the answer is maybe, kind of, sort of. All right, your question.
So in the slides, there's a picture from the surface, and it shows that the sky is like a yellowish green. What does that tell us about the makeup of the atmosphere?
I imagine the colors
False
come from
colors.
some of the, I think the CO2 is pretty not colorful, but the sulfur, I think there's sulfur clouds, maybe some of the yellow.
Yeah.
I didn't actually study up on that, but I think it's the trace constituents that give it the color.
I didn't even see that.
Yeah, so those are very nice images. But if you Google Don Mitchell, he reprocessed some of the Venera landing, many of the Venera landing pictures and undistorted them, and so they're very spectacular. So if you Google Don Mitchell Venus, you'll have his reprocessing of all the Venus lander images. They're very spectacular.
Before the pep band plays us out, remain seated, please. We want to tell you about our next event, the Embry-Riddle Speaker Series. It'll be next Monday night. The Pilot Shortage 2.0, being presented by, in part, our alumni department here at the campus of Embry-Riddle. How short are we on pilots? What industries are going to be hiring? Tell your friends, students, please come back. We'll have 2 experts to talk about that next Monday night at 7 o'clock right here on the campus of Embry-Riddle. Once again, I want to thank our panelists, Dr. Ashley Kehoe, Dr. Jason Aufdenberg, and the Reverend David Keck for being with us tonight.
And one thing before, as we transition, is we might want to remember the music you're about to hear might be familiar. The person who composed it was drawing off of Gustav Holst and the work of the planet. So that's our connection. So I want to make sure that gets lifted up.
There you go. I appreciate that. Carter, take us out. Thank you all for coming tonight. Thank you all for coming. Have a pleasant good evening.